The electrostatic series. So the electrostatic series is a list that we can use to determine who's the best at holding on to their electrons and who's the worst at holding on to their electrons. The way that this electrostatic series is organized, the materials on the bottom are very good at holding on to their electrons. So when they exchange electrons with another material, they don't tend to give theirs up. They tend to hold on to them, and so they tend to end up with an excess of electrons, and they tend to end up being negative. Alternatively, the materials on the top, like the human skin and the rabbit fur, give up electrons easily. Which means in the exchange of electrons, they give up a lot of electrons, which means they end up with a deficit of electrons, which means they end up being positive. So let's just take a couple examples here. Let's say we have rabbit fur and we rub it on a rubber balloon. So if this is our rabbit fur and this is our rubber balloon, then before the exchange, we're going to assume that they are both neutral objects. They have the same number of pluses and minuses. Here I've used 4 protons and 4 electrons, so that's neutral. This is initial or before. And with my balloon, same thing. I'll give it 4 and 4, making it neutral to start. Sorry, that's confusing. 4 protons and 4 electrons, giving me no charge or neutral. And then I'm going to rub the two things together. Now what we're assuming here, or well, not assuming, we're looking at our electrostatic series. We're saying that the balloon is lower, which means he's better at holding on to his electrons. So maybe during the exchange, he'll only pass 1 over. Alternatively, the rabbit fur way up here is not so good at holding his electrons, so he's going to pass over, say, 3, which means the fur, having stolen 1 electron from the balloon but given up 3, will be down to 2 electrons. 4, given up 3, taken 1, leaving him at 2. In the balloon, having taken in 3 electrons and only given up 1, will be up to 6 electrons. 1, 2, 3, 4, 5, 6. So that means now that the fur will have 4 protons and 2 electrons, or plus 4 minus 2, or a net charge of plus 2. It'll be positive. And the balloon will have 4 protons and 6 electrons, so plus 4 minus 6, or a net charge of minus 2, and it will be negative. So, because the fur gave up its electrons easily, it ended up with a deficit of electrons and ended up being positive. And since the balloon held on to his electrons hard, he ended up getting more electrons than he gave up, ending up with an excess of electrons, or becoming negative. What could you use to make silk positively charged? So how can we use this? Well, let's say I have this material silk, and I want to make silk positive. So I want silk to be the positive. What that means then is that the silk should end up with a deficit of electrons, or it should give more electrons than it gets. What does that mean? Well, that means I need to pair it with something that has a stronger hold on its electrons. So where are those guys? Well, they're here. So I could use anything from the bottom of this chart. In this case, I'd probably pick something common like the rubber balloon. The balloon has a stronger hold on the electrons because it's lower on the chart. So the balloon, just like it did with the fur, will end up taking more electrons and leaving the silk, just like the fur, positive in the end. And that means that if I rubbed silk with my rubber balloon, my silk would become positive. So that's how I can use the electrostatic series to predict which object will become positive or negative, and also how I can use it to choose a material that will get me the charge that I want on the material that I want.